again, is the center of gravity. And then if we were to look at the I, right? If we want to find I from point A, so this is the A now, okay? I from point A. So this will be equal to Ig plus by mb squared. Okay. So Ig over here is the mass moment of inertia. Oh, shit. Sorry. Oh, this time I really forgot. Oh, I did not. Okay. But I know it's a repeating pattern. There's a disorder about me. Okay. The body mass center, M is the mass of the body. And then you have D, which correspond to perpendicular distance. Between the parallel axis. Okay. And note most of the time we are going to deal with planar motion. Okay. So the motion is on a plane. Okay. Now some of you might wonder how to determine Ig. Okay. How to determine I, the mass moment of inertia. I'm not going to do the math of it. Okay. We are just going to apply. So on Wednesday lecture, if you go to the next page, you'll have this, yes or no? Right? You're seeing this, yes or no? This is on, if I were to go to week 12 or week 11, and it's on Wednesday notes. Did I post it? If you go right to the end, okay, I posted a table that will be given to you in the exam, okay, regarding the mass moment of inertia of different shapes. Okay, so these are the shapes that we'll be dealing with. Okay, just to let you know. So this is how we get our Ig. Okay, so let me come to here. Okay, paste it over here. As I said, I will provide this table. Okay, I don't expect you all to memorize it. Okay, it's ridiculous to memorize it, I think. Okay, so you can, now what I'm going to do, have you seen a table like this before? Some of you, yes, some of you know. So what I'm going to do is I'm going to teach you how to use this table. Okay, I'm going to teach you how to use this table, and by doing a simple example. Okay, and this example can be taken. Where was it? Over here. Okay, we're going to do this example now. Okay. Okay, example number 1. It states that the slender rod have a weight of 3 pounds per feet. Determine the moment of inertia of the assembly about an axis perpendicular, okay, perpendicular to the page and passing through point A. Okay. So first of all, what we realize that they already verified for us that this is a what? Slender rod. So why do they need to verify to us what is slender rod? Okay. So if you go to the table, okay, there's two possibility, right? One, it can be a what? Cylinder. Can you see the table over here? One can be the cylinder, right? And the other one specified down here as a what? Slender rod. We clear? From here, all you need to do now, you go to over here, or you go to the image, and you're going to take this thing. Okay. And then we are going to come here, and we're going to paste here. Why I took this diagram? Because this is the diagram that we are going to what? That we're going to use. Okay. Right. So there's two things we need to take note. Okay. So let's focus on the formula below. Okay. So when it is Ixx and Iyy, right? The formula that we use is 1 12 ml squared. Okay. And then if we are looking at this point over here, right? Then the formula that we're going to use, or the axis will be what? X prime and Y prime. Then the formula we're going to use is 1/3 ml squared. If it's along the ZZ prime axis, the moment of inertia is equal to 0. Okay. Now, let me ask you a question now. Okay. It states that we are going to determine the moment of inertia about an axis perpendicular to the page. Why is it important to find the moment of inertia about or perpendicular to the page? Before we ask why, can you visualize how the structure will move? Is the structure going to move left and right? It can't. Is the structure is going to move up and down? It can't. Why? Anyone? Because this is a what? This is a pin. When it is a pin, right, we know that x is equal to 0, y is equal to 0. I will write down my transformation over here. This is x and this is y, and over here is rotation about z. We know that moment about z is not equal to what? It's not equal to 0. Agree or disagree? Moment about z is not equal to what? 0. For this reason, this thing will swing what? Alpha or omega will act in either of this direction. It's a curvature direction. Is this very clear? Okay. How many of you down here are going to have 2P term test? Okay, Dr. Koshi talked about free body diagram already, yes or no? Yes? Okay, so you have to be really solid about this, okay? So now we know that the rotation is about what? about the z-axis. Okay, I mean based on this transformation. So over here, we can either use IYY, sorry, IXX, or we can use what? IYY. Are we clear on the figure? Okay. Right. So the first thing that we're going to do, okay, we are going to, so I'm going to call this our vertical rod. And I'm going to call this our horizontal rod. Okay, one is a vertical rod and one is a horizontal rod. Okay, so I'm going to paste this diagram over here. Okay, so now let's focus on our vertical rod. So our vertical rod, the general formula, as we know, is I is equal to IG plus by MD squared. Okay, so I is equal to IG MD squared. Okay, so the vertical rod, there are two ways that we can do this. Okay, so the first method, number one, okay, we are going to use IXX, okay, which is equal to 112 ml squared. Okay, so method number one, we are going to use the 1/12. So if we were to use our 1/12, okay, so we know that I, for the vertical, okay, V for vertical rod, VR for vertical rod. So this will be equal to 1/12, okay, ml squared, plus by the mass, and then the D is equal to what? L/2, and then we square. Why is this equal to L? If over here, this entire length is equal to L, we know over here, this is the G for the what? Vertical rod only. Okay, that is the vertical rod only. So over here, you can get 1/12 ml squared plus by m L squared over 4. And this will become what? Will become ml squared over what? Over 3. Okay. So if we were to use the original formula, 1/12, the mass is what? So we are given that the weight, okay, I have to step back. The weight is 3 pounds per feet. Okay, I have to convert to mass. Okay, so we have to determine mass of vertical rod. So this will become 3 multiplied by 3 divided by 32.2. The number looks familiar. So it's equal to 0.28. Okay, 0.28 what? Slug. Okay, so from here, if we were to just apply this formula, I for vertical rod is equal to 1/12 multiplied by 0.28. Length is